The idea that humans will eventually travel to and inhabit other parts of our galaxy was perhaps best expressed by the early Russian rocket scientist Konstantin Tsiolkovsky, who wrote, "The Earth is the cradle of humanity, but mankind cannot stay in the cradle forever." Since then, the idea has been a staple of science fiction, and thus become part of a consensus image of humanity's future. Going to the stars is often regarded as humanity's destination, even a measure of its success as a species. But the immense distances to neighboring star systems and the inhospitable conditions pose the single greatest challenge to a true interstellar mission. Currently, the leading concept for interstellar space colonization is known as the Embryo Space Colonization theory. Put simply, it involves sending a robotic mission to a habitable terrestrial planet or other celestial body with a payload of frozen early-stage human embryos or biological means to create them. Embryo space colonization has three potential timeframes when it could be applied. The first option is near-term, a low-speed escape mission to a nearby star to provide a backup or reboot of the human species. The second option is mid-term, a mission traveling at moderate speeds to set up research colonies or industrial complexes. The third option is far-term, colonizing habitable environments while implementing genetic modification techniques, allowing us to survive in harsh planetary conditions. If we were going to carry out the near-term option, it would more than likely be in the face of a catastrophic extinction risk. A prudent approach to this situation would be to launch a species reboot as a fallback option. Due to the limited time available to develop this technology in light of a global extinction, we would have to use current propulsion technology. To do so, we need to use the available free energy of our environment, chiefly nuclear, and the sun's photon and solar wind flux. Carrying out a midterm launch would give us more time to prepare more ambitious goals at the destination than a mere colony. An industrial civilization in embryo could be sent. Previous studies have estimated that a 1,000-ton payload could kickstart a self-sufficient industrial space complex. The far-term option allows for plenty of time to prepare for the trip, and even possibly alter the human genome to enable fast adaptation of humans to novel environments, a process known as pantropy. As human engineering remains purely speculative, only tentative suggestions can be made. One suggestion being the use of hydrogen as a greenhouse gas for planet colonization. Planets are able to be warmed to Earth-like temperatures via dense hydrogen greenhouse atmospheres. We may be able to utilize a tiny cellular structure found within bacteria called a hydrogenosome, allowing us to thrive in these conditions. This has already been tested successfully in pigs, and may be incorporated directly into human embryos, perhaps more successfully than with adult humans. Another suggestion is to create oxygenated closed oceans, such as those found on Jupiter's moon, Europa, which could exist beneath the ice of many extrasolar planet moons, providing a potentially viable habitat for modified humans. Another thing to keep in mind is ammonia tolerance. Guano bats can survive high levels of ammonia, which would otherwise prove fatal to other mammals. This could be bioengineered directly. Ammonia could possibly build up in atmospheres of planets orbiting red dwarf stars, due to the lower UV flux of older dwarf stars. Although this involves quite a lot of speculation, embryo space colonization may be a potential tool in the adaptation of humans, and could possibly be the key that will allow us to inhabit the cosmos. Recently, the idea of android parenting and robotic care seems far-fetched, but equally, trends in that direction are developing. If the reliability of the machinery can be assumed, which isn't a small task in itself, then missions of centuries to millennia can be contemplated and hopefully carried out. Thanks for watching this episode of Top Science Facts. We love the fact that you guys leave comments, so make sure you do that with other questions you want us to answer. and make sure to subscribe for more episodes like this one.